Hello, thank you for checking out my video, and today we're taking a look at half-life and doubling life. Okay, alright, this is building on our exponential function formula. Y is equal to a b raised to the x or t, and we're making some alterations to the b and the x, mostly the x on this one. So I'm going to show you the formula for half-life and double life and then go from there. So here's the formula. Alright, so we've got the halving formula has a half for the b, and you're going to divide the time by the number of times you halve it. And then the doubling formula, you guessed it, has a 2 for the b, and you're going to double, you're going to divide the time by the number of times you double. Okay, pretty simple. So we're going to take a look at some word problems and figure out if we're using the halving formula or the doubling formula. Okay, and then plug in all our variables or all our knowns here and type it in the calculator and get the answer. Alright, so now I'm going to make a slight alteration to the halving formula here. Instead of using 1/2 and having that fraction in there, just use 0.5, because 0.5 is the same as 1/2, and then we'll raise it to the t over h. Alright, so let's take a look at an example. A new car is purchased at $45,000, and over time its value depreciates by 1/2 every 3.5 years. What is the value of the car 17 years after it was purchased to the nearest $100? Alright, so what you want to do is, I want to show you this. This one right here is one where you're going to have an exponential function going down, and this one's one where you're going to have it going up, because that b on there is going, this is less than or in between 0 and 1, and this is 1 or greater. So pay close attention to that. So, but this one is a half, so we're going to use the half formula, which is y is equal to a times 0.5 raised to the t over h. Okay, and we're going to plug in everything we need. So the y is going to be our answer here, and a is where we're going to begin with, 45,000. Alright, and we're going to put in the 0.5 because it's a halving formula, and now all we got to do is put in our t and h. Well, t is the number of years total, so that's 17, and we're going to divide that by however many times we halve it. We halve it every 3.5 years, so that's going to be 3.5. So then all you got to do is type this into the calculator, make sure you raise it to this exponent, and type your fraction in there. If you need to, put the fraction in parentheses and hit enter. Then once you do that, you get this number here. Okay, get this number here. So we want to round it to the nearest $100. Okay, nearest $100. So you'll go and try to get to the $100. The 100th place is right here, that 5. If I can have a thinner one. How about this? It's just 5. Okay, nope, not that 5, the other 5. Okay, so 10 ones, 10s, 100. Okay, so we're rounding here. So we're going to look at the number next to it, this number here. Alright, and we're going to determine whether to go up or down. So the 5, if it's 5 or higher, we're going to go up. So we raise it to 6 and make the rest of the numbers 0. So that's how we end up with 1,600. Round to the nearest $100. Alright, let's take a look at another example. Okay, you can pause the video here and see if you can solve this one. Okay, so it says element X is radioactive isotope such that every 3 years its masses decrease by half, given that the initial mass of a sample of element X is 410 grams, how much of the element would remain after 10 years to the nearest whole number? Alright, so this one is, again, we want to half. So we're going to use the half formula, which is y is equal to a times 0.5 raised to the t over h. Okay, so a is the amount we start with, which is 410 grams. Okay, and we're going to multiply by 0.5 because it's a halving formula. Alright, we're going to raise it to the time, the total time. Now this is where it gets tricky. You got 3 years here, and you got 10 years here. Which one do you use? Well, the total time is what you want to do. So put in the numerator. So the total time is 10 years. So we're going to put in 10 years. And divide it by when does it halves. So it halves every 3 years. So that's going to be here. So then you just type that all into your calculator, and you end up with this here. Alright, so once you do that, here it says to round to the nearest whole number, right? So the nearest whole number is right here. So we're going to look to the number to the right of it. Alright, and determine, do we go up or down? Well, it's 5 or higher, it's 6, so we're going to go up on the yellow, this number here, in the ones place. So that's how you can end up with 41. Alright, let's take a look at another example. Okay, so in a lab experiment, 5,400 bacteria are placed in a petri dish. The conditions are such that the number of bacteria is able to double every 4 hours. How many bacteria would there be after 17 hours to the nearest whole number? Well, since we're doubling here, we want to use the doubling formula. And the doubling formula is going to be y is equal to a times 2 raised to the t over d, because we're doubling. And now we're just going to plug in these elements here. We're going to plug in the 5,400 because that's where we begin with. We're going to multiply that times 2. And we're going to raise it to the total number of hours here, which is 17. And divide it by however many times it doubles, 4. So what that does is, once you divide by that number, it tells you how many times you have to compound it, really. How many times. So that's what you're trying to find out there. So you got 17 over 4. And we're going to type this straight to the calculator. And we get this. Okay. Now this one's another one where we want to round to the nearest whole number. Okay. So we're going to look at this number here, and then that's what we want to focus on, and we're looking at the number to the right of it. To the right of it is 4 this time. It's less than 5. So we leave off everything else and just keep the 7, 7. It stays the 7. So that's how you round to the nearest whole number on that one. Alright, let's take a look at another example. Alright, you can pause the video here and see if you can solve this one on your own. Okay, so let's take a look. It says a person invested $7,300 in an account, growing at a rate allowing the money to double every 14 years. How much money would be in the account after 15 years? To the nearest dollar. Okay, That almost seems weird. You got it doubles every 14, then 15, just 1 year different. But we're just gonna follow the formula and go from there. So the formula is y is equal to a times 2 raised to the t over d. Okay, so y is equal to the 7,300 times 2, and we're going to put the 15 and divide it by 14. And once we type that into the calculator, we get this. Alright, and this will says round to the nearest dollar, which would be the whole dollar here. So that's what we're going to do. We're going to focus on this number here. Realize that the number to the right of it is 0, so it's less than 5. We're going to drop off the rest of this and leave the 1, and this is how we get that. And that's it. That is doubling and half-life. I'm going to leave you with the formulas here to take a look at again, and I want to thank you for checking out my video. Have a nice day.